Hey, now we're going to look at parallel perpendicular lines. So what makes lines parallel? Well, parallel lines, I call them railroad tracks. And the reason I call them railroad tracks is because railroad tracks run parallel. The tracks never touch each other, and that makes them parallel lines. Well, notice these parallel lines have exactly the same amount of slant. And so parallel lines have the same slope. So if the slope of this line is, let's see, well, it might be about a 1, and the slope of this line is equal to 1, then that means I have parallel lines. So if I give you an equation such as, well, we won't do it with the equation right now. We'll wait for the next lesson for that. So if I have ordered pairs, and I find in doing those two sets of ordered pairs, I end up with the same slope, then that means I have parallel lines. On the other hand, a line that is perpendicular is a line that makes a 90-degree angle with another line. So this line would be perpendicular to these two lines. So what's happening here? Well, first of all, notice that if this line has a positive slope, a perpendicular line has a negative slope. And it turns out that the slope of the perpendicular line is exactly the opposite reciprocal. So say this was 1/2. We're just going to change the slope. This line would be m equals -2/1, which is equal to a -2. So we have the opposite reciprocal of that. So perpendicular lines have slopes which are opposite reciprocals of each other. So if one is positive, the other one is negative. And if the fraction is flipped upside down, it's the reciprocal, the flipping of it. That is one way to define perpendicular lines. Another way to define it is that perpendicular lines have slopes which equal -1 when multiplied. In other words, on this example that I have right here, one slope is 1/2, the other slope is -2/1. This is equal to -2/2, which is equal to a -1. So notice that the product of the two slopes equals a -1. So this tells us whether lines are parallel, whether they're perpendicular to each other. So, how are we going to do this? Well, first of all, you have to have two sets of ordered pairs because you need one set of two for each slope. So let's look and let's see what happens when we do that. Let's take some examples here. Say I have a set of ordered pairs, -4, -6, and here's one set, -6, -5. There is one set of ordered pairs, and now let's look at the other set of ordered pairs. -3, -8, and -5, -7. Let's find out. Do the lines these form, are they parallel? Are they perpendicular? Or are they neither parallel or perpendicular? So let's figure the slope. M is equal to -5 minus a -6 over -6 minus a -4. Well, let's fix it. So we have -5 plus 6, and this is -6 plus 4. This gives me a slope of 1 over -2, which equals a -1/2, okay? That's my first slope. Let's do my second slope. M is equal to -7 minus a -8 over -5 minus a -3, which equals -7 plus 8, -5 plus 3, and this gives me a 1 over 2. So my M is equal to 1/2. Well, notice, in spite of the fact that the negative and this one is positive, they are not reciprocals of each other because the signs are different. They are not the exact same slope. Therefore, this set of ordered pairs is neither parallel nor perpendicular. We could have actually plotted the points on a graph, and we could have looked at it that way and told what we were dealing with as well. Let's see. Okay, let's plot the first set of ordered pairs. -4, -6. There's one dot. -6, -5. There's the other dot. Okay. There's one of the lines. Let's continue. Whoops. I'm curving my line. Let's see if we can get it fairly straight here. There's one line. Not very good. Okay, let's look at the other one. -3, -8. I'm going to carry this down further. Okay, there's one point. And -5, -7. Okay, now look at these two lines. Turns out they do intersect, but their intersection point doesn't make a 90-degree angle. They're actually very close to each other. So somewhere here, you see that's your intersection point. It doesn't form a 90-degree angle because they intersect. They are not parallel to each other. And therefore, that's what's going on. Really? -3, -8, -5, -7. That should be a positive. Let me check my math here. Oh, no. That one is actually the same. Look at that. I did make a mistake on it. And my graph is off because I don't have an accurate graph drawn. But you could do it with a graph too, and you would have seen that they are the same. Do you see my mistake? I said that was a 2 instead of a -2. -5 plus 3 is a -2. And that made a -1/2 and a -1/2. Therefore, these two lines are parallel. Sorry about the mistake, guys. So, as you can see, it's easy to make mistakes if you're not careful. I made a very simple integer addition mistake here. Negative 5 plus 3 is a negative 2. So be sure to check yourself. How did I know it was incorrect? I knew it was incorrect because I had a positive slope here, but my line that I drew had a negative slope. So I knew there had to be a mistake somewhere. So don't be afraid to recognize that you can make mistakes on these. It's okay. You just go back and you fix it, okay? So let's look at another example and see what we come up on that one. Okay? Negative 2, negative 8, and 0, negative 4. That's one set of ordered pairs. My second set of ordered pairs is 0, negative 4, and 2, negative 3. Okay, so let's do the first one. So my m is equal to negative 4 minus negative 8 over 0 minus negative 2. And this is equal to negative 4 plus 8 over 0 plus 2, which equals 4 over 2, which means m equals a positive 2 because 4 divided by 2 is 2. Now let's do this one. M equals negative 3 minus negative 4 over 2 minus 0. So this is negative 3 plus 4. 2 minus 0 is 2. And this becomes a positive 1/2. Okay. Notice they're reciprocals of each other, but unless I've made a mistake, this one is positive, and this one is positive. So they are not opposite reciprocals. So this again, what I thought was the other one, this one would be neither. Okay, but now let's draw a picture of it. We can graph it and check ourselves out. Okay, let's see how accurate my drawing is this time. Last time it wasn't very good. Okay. Okay, negative 2, negative 8. 1, 2, 3, 4, 5, 6, 7, 8. There's 1 point and 0, negative 4. There's my other point. Okay, there's one line. And that's a positive slope, just like it said. Okay, now let's look at 0, negative 4. That's my second one. And 2, negative 3. Oops, too close. Move it over a little bit. There we go. Notice it does have a point of intersection, and they're both positive slopes, so that's good. And notice at the point of intersection, I don't have 90-degree angles. Therefore, just like it's said up here, it is neither perpendicular nor parallel. Okay, let's do one more. And let's see what happens on this one. I have a negative 3, and 8, 7. That's my first ordered pair. My second ordered pair is 10, negative 6, and 0, 5. Okay, so let's do these, and first of all, let's calculate them, and then we'll draw the picture, just like we have. Okay, this we have m is equal to 7 minus negative 3 over 8 minus negative 3 equals 7 plus 3 over 8 plus 3 equals 10 over 11. Okay, let's do the next one. M equals 5 minus negative 6 over 0 minus 10, which equals 5 plus 6 over 0 minus 10. That gives me 11 over negative 10, which means my M is equal to negative 11 tenths. Notice, same numbers, only reciprocals of each other. 10 11ths, 11 tenths, those are reciprocals, positive, negative. So according to my slopes, this one is actually perpendicular. And now let's draw the picture and see if the picture actually matches what we've got here. 8, 7, okay. Guess we'll have to make it smaller. Okay, negative 3, negative 3. There's one of them. 8, 7, 2, 4, 6, 8, up 7. There's my other point. Long way apart, hard to draw an accurate line. But anyway, there we go, somewhat. And now 10, negative 6, and 0, 5. Yeah, that looks pretty close to a right angle. Not too bad. Again, because I don't have accurate graph paper, it's hard to see exactly, but that basically looks like a right angle. So you can see right angles, all of these are right angles, therefore we have perpendicular lines. Okay, that's the end of this. Have fun on this assignment and have a good time.